Here we go again. All right, so here's the question about electromagnetic induction. It's a very nice question. Let's read together and answer it properly. The diagram shows a permanent magnet placed inside a coil from the direction of the arrow. All right, you can see the magnet is being pushed in that direction. And we have the south pole here and the north pole here. What should be the response on the needle on G as what? As the magnet was being pushed inside the coil. You can pause the video as always. Like I said, you can pause the video and you can actually try to answer it. Well, let's say if we push this magnet by electromagnetic induction, or what we mean is that there will be an EMF. There will be an EMF, what? EMF, which is electromotive force, which will be induced. Now, once this electromotive force is induced, it produces an electric current. Okay? Now, once this electric current is produced, here's what happens. It flows in the direction so as to oppose the change that caused it. That is Lenz's law. That is what Lenz's law. Well, so this is a very good concept, ladies and gentlemen. A very good concept. Now, listen, come closer. Come close. Now, here's the thing. It is the change in the magnetic field that induces this EMF. I'm explaining this so that you can actually listen to why it is like that. So that change in the magnetic field, or we can say the magnetic flux, it causes the induction of the EMF. Now this EMF produces an electric current. Now this electric current will flow in the direction so as to oppose the change that caused it. And that's what I said, Lenz's law. Now, before I even come to the answer, there are key concepts here that you need to understand before I even pick which one is the correct answer. Because all what we need to decide here, whether it went to the right or to the what? Left. But there are key concepts behind what? Behind that. Let's first analyze the situation, all right? Since the magnet is being pushed inside, right? That means we are increasing the magnetic field. Take note of that. We are increasing the magnetic field. The fact that we are moving from south to north, we are increasing the magnetic field. It's simple as that. Now, as we are increasing the magnetic field, remember that the electric current is supposed to oppose that increase. So how is the electric current going to oppose that increase? It has to flow in the opposite direction to decrease, all right, that change that caused it. This is where we are saying is Lenz's law, all right? Now, to know the direction of the current, of course, I said we are going to use Lenz's law, and we can also use the right-hand rule, which I can't show it properly here, but you research on the right-hand rule and the right-hand grip rule. Research on those; they are quite important. Now, without even going much into details, as you can see, since we are saying as the EMF gets induced, electric current is produced, and that current should flow in the opposite direction. So I know you will expect this galvanometer to deflect in the right direction, but no. According to Lenz's law, it should actually flow in the opposite direction so as to oppose the change that caused it. So that's why we are saying it will flow instead to the what? To the left side of the galvanometer. So the galvanometer will deflect in the left hand side based on those key concepts, Lenz's law and the right hand rule. Please combine them. I hope you get the meaning. Someone should be able to explain to you what is happening here. You can join online classes. You can also comment, share, and follow me on TikTok and Facebook. Well, I appreciate. Vamos.